Okay, so you made one question in your homework. I think you ended up getting Tn as half of n squared plus half of n. Give me the terms of the pattern again. There was 1 then.
It was 1, 3.
1, then 3, then
6.
6, and then
10.
10,
Then 15.
then 15. We can stop there. Right. These are called triangular numbers. I think it's easy to understand why they are called triangular numbers. Because if you can imagine it properly, that's a triangle there with one dot. This is another triangle here with 3 dots. Like if I join like that, I can get a triangle. So for that one, I've got 1, then I've got 2 here, then I've got 3 here. But the thing is, if I join this like that, I kind of get a triangle. And that is actually what we get even for 10, 15, and so on. So yeah, these are called triangular numbers. We have other types of numbers as well. For instance, we have pentagonal numbers. So the dots are arranged in such a way that you can get a pentagon. But let's look at 1, 3, 6, 10, 15, and so on. I think you know that this is quadratic, right? How do you know that it's quadratic? We know this is quadratic. And you can check that it's quadratic by looking for the differences. 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. 15 minus 10 is 5. So the first differences are not constant, which means this is not linear. But if you continue, you will notice that the second differences are actually constant. And therefore, this is a quadratic number pattern. It is harmless to learn this now, but you learn it properly. It's actually in the grade 11 syllabus. These numbers are very important. I want us to investigate those numbers together. Right, and let's do it this way. Because this is a quadratic number pattern, we actually call it quadratic because Tn will be a quadratic function. Now we know quadratic functions. Do you remember that a quadratic function f of x would look like something like this? You remember that, right? So that's our quadratic function. But we are dealing with number patterns, and we are looking for the nth term. So in our case, we can't say f of x, we'll say f of n. And we will write it as an squared plus bn plus c. And we usually just refer to it as tn instead of f of n. So tn should be equal to n squared plus bn plus c. Obviously, a, b, and c are just real numbers. These are elements of the real numbers. So tell me, we are saying Tn is equal to an squared plus bn plus c. So what is T1 equal to? That means we should just replace n with 1, right? So this will become a multiplied by 1 squared plus b multiplied by 1 plus c. But that will simplify to a plus b plus c. Let's look for a few more. The a multiplied by 2 squared there, plus b multiplied by 2 plus c. And what do we get? We get 4a plus 2b plus c, right? Okay, let's look for T3. I think we can go to the answer straight away. We know that we're going to replace n with 3. So what will you get finally? 9a plus 3b plus C. I need two more. T4, 16A plus 4B plus C. Let's end with 5. T5, 25A plus 5B plus C. Okay, so these are just the first 5 terms of this particular quadratic number pattern. I will just arrange these numbers like this. I'll put T1 here, which is our A plus B plus C. Then I'll put T2 here, which is 4A plus 2B plus C. Then put T3 here, which is 9A plus 3B plus C. T4 is 16A plus 4B plus C. I'll try and squeeze in T5 there. We don't really need it. I think we have enough. I have no space, but T5 is 25A plus 5B plus C. Okay. So these are our terms. Now let's look for the differences. What is T2 minus T1 equal to? T2 minus T1 will give us 3A plus B. Do you see that? All right. What is T3 subtract T2? 5A plus B. And what is T4 minus T3? 7A plus B. Okay, good. The last one, T5 minus T4, 9A plus B. Do you see that the first differences are not the same? And this is because this is not a linear pattern. Now let's look for the second differences. What is 5A plus B? Subtract 3A plus B. You get 2A. And what is 7A plus B? Subtract 5A plus B. Again, you get 2A. And what is 9A plus B? Subtract that one, so you get 2A, right? Okay. And then I said for the first one there, I said these numbers here become very, very important, right? And this is what we're going to use actually. So if you get a quadratic number pattern, you need to work out your first differences as well as your second differences. Then the number that is in this position must always be put equal to 2A. So 2A is always equal to the number that is here. 3A plus B is equal to the number that is there. Then A plus B plus C is equal to the number that is there. And that is how we actually get the general formula. So if you go back to your number sequence 1, 3, 6, if you go back to 1, 3, 6, 10, 15, this one gives you 2, that one gives you 3, that one gives you 4, that one gives you 5. This one gives you 1, that one gives you 1, that one gives you 1. So I'm saying these numbers are very important. Right, but we now need to solve. We will start from the bottom going up. So this number should be equal to 2A from that previous generalization, you remember. So we said everything that ends up here should be equal to 2A. But right now, we have 1 there. So it means 2A is equal to 1. And what about that one there? That one should be 3A plus B. Okay, so this is 3A plus B. And the other one, that one will be A plus B plus C. Okay. So yeah, starting with 2A is equal to 1. You will notice you get A is equal to 1 over 2. Then you move up to 3A plus B is equal to 2. So 3A plus B is equal to 2 in this case. But we know what A is. A is equal to 1 over 2. So we can find B from there now. So B will be 2 subtract 3 multiplied by A, but A is that. What is 2 subtract 1.5? it's half again. Okay, so we get 1 over 2. Then finally, the number that's here should be put equal to a plus b plus c. So you form your equation again, a plus b plus c, in this case is equal to 1. But we know that a is 1 over 2, and b is 1 over 2, and we are trying to find c. So you will notice that c will be equal to 0 in this case, because 1 over 2 plus 1 over 2 is equal to 1. If you move it to the other side, you will get a 0, so c is equal to 0. Then you go back now to your general rule, which is an squared plus bn plus c, and you replace there. Just substitute into that. So we know a is 1 over 2, so this becomes 1 over 2n squared. We know b is also 1 over 2, so this is 1 over 2n. We know c is 0, there's no need to write it, and so you get your answer like that.